Hello everyone. Today we're going to answer the question, how do you use EventBridge? And by the end of this episode you will know why EventBridge is very different from everything else in the space. We will also discuss some interesting examples on when and how you can use EventBridge, what can possibly go wrong with it and how much are you going to pay for it. And finally we are going to give you some tips to avoid shooting yourself in the foot and get good observability. My name is Luciano and today I'm joined by Eoin and this is AWS Bytes podcast. So before we get started, let me mention that this is a series about AWS services that cover the space of event and message passing. We just finished an episode about SQS, the previous one, and we also had a more generic introduction to all these services. Today we're going to focus on EventBridge, but if you're interested in the space, make sure to follow and subscribe so you can be notified whenever we publish the next events. But back to EventBridge. Eoin, what can you tell us about what are the main features or the main things why EventBridge is so interesting?
Yeah, EventBridge, if we talk about the classification we previously used, we had queues and then we had PubSub and then streaming. EventBridge we put in the PubSub category, but it's a little bit different to other PubSub systems. It's got some interesting features. So EventBridge is nice in that you have you can publish events without really provisioning anything up front. That's, I think, the thing that people really like. You don't have to provision any resources in AWS if you want to send events to it. But if you want to consume them, then you just need to create a rule. And that's how it works. So you don't really have the subscriber concept like you do with SNS. You don't necessarily have to have listeners. Instead, you have rules. And a rule is slightly different to a subscription. With a rule, you define a pattern. And it is really like a pattern matching concept, similar to the kind of pattern matching concept you get in some programming languages, where you have an event and you're trying to say, I want to receive events that look a little bit like this pattern here. And then you can specify some properties in that event and their values, this partial string that it might begin with, integer comparison. And then you say, okay, with this rule, if you find any matches, then can you please send these events to these targets? And one of the great things about EventBridge is that it supports lots of targets. So EventBridge is really good. It's almost like the integrate anything with anything service on AWS. So it's, of all the services we're going to talk about in this series, it's probably the most general purpose. It can do almost anything you can imagine. There are, of course, some limitations, which we'll talk about, but it is really, really powerful. And it's one of the services that has really got a lot of people excited since it was announced. It was actually based off a service that had existed for a long time, CloudWatch Events, but they rebranded it and gave it a new purpose and added a lot of new features. And suddenly people are getting as excited about it as almost as people did when Lambda came out. So there's lots of different features in it. So you got different event types. Do you want to talk about maybe what are the different events you can get with EventBridge?
Yeah, before that, I just want to mention that it reminds me a little bit in its purpose and the way it has been marketed as the if this then that or Zapier answer from AWS, right? Yeah.
Yep, absolutely.
So, yeah, different type of events. So there are actually, I would say, 3 main categories of events that you can deal with. And the first one is that there are events that are, I would call them native in AWS. So things that happen in your AWS account or other accounts, and you might want to listen for and react to them. And just to give you a few examples, for instance, you can be notified whenever a spot instance has been interrupted, or maybe you have step functions and you want to react to a step function changing state. Maybe it's started, maybe it's failing, maybe it's timing out. And for instance, you can even enable notifications and events for S3 objects. So you could say every time there is a new object in a bucket, trigger that this is an event, and you can create a rule to match that. And very generic thing, you can use CloudTrail as well, and that will give you access to another wide range of events. There is a list that we will put in the show descriptions. There is a link there, and you will find there all the events and services from AWS that will trigger events that you can capture in EventBridge. There is an interesting small detail that you need to be a little bit careful about. There are different guarantees in terms of delivery, depending on the type of event source that you are trying to use. Sometimes you have kind of a guaranteed delivery, and then sometimes you have best effort. So I suppose that pretty much means when you get at least once delivery or at most once type of delivery.
Yeah. I guess if it's best effort, it's kind of at least 0, right? Because you just, for some of those services, you just won't get an event. So yeah, it's good to check the docs.
So this is the first category, and it's something that it's there for you. If you want to use it, you just create a rule and you use it. In some cases, you need to enable the events, but most of the time it's there and it works for you. Then there are another category that is partner events, and this is actually really interesting, and this is why sometimes I like to think about EventBridge as sort of a Zapier or if this then that, because you can plug in events from other SaaS platforms. For instance, I don't know, Salesforce, OutZero, PagerDuty. So if you integrate the platform with your AWS account, basically you can start to get events from those other external platforms and consume them. I don't know, an example that comes to mind, maybe you have a sales pipeline that you are mapping in Salesforce. If that pipeline changes, maybe you have new deals coming in, you can probably receive events and react to those and create integrations. And finally, the third category of events is custom events. So you can use the SDK to dispatch your own totally custom events. For instance, I don't know, if you are building an e-commerce, which seems to be our favorite example, you could create your own custom events every time there is a new order, and you can define the structure of those events, and then different parts of your application can create patterns and rules to capture those events and react to them. That's all I have for events, but what about targets?
I mentioned that one of the advantages is that you have loads of targets. So compared to SNS or SQS, you've many services that you can integrate directly from EventBridge. You also have HTTP destinations. So if you've got a third-party API, you can use EventBridge to route all of these different types of messages that can come in to a third-party API or an external API or one of your other APIs. And it also supports neat things like throttling and exponential back off and retry. So that's really useful. And one of the great things that EventBridge has that a lot of other services doesn't have is cross-account EventBridge. So you can, if you've got different applications, different domains running in different accounts, or even third-party events, you can set other event bridges and other accounts as a target. So that makes it really easy to integrate without having to have, specific services that are there with an IAM policy and network routing that can route from one account to another that you have to do with some other kinds of services. EventBridge takes care of that. So there's definitely the richest supported set of supported targets available. I suppose there's a couple of other features that came out after EventBridge was launched: the Schema Registry and then the archive and replay. And for people who have a lot of events in their system and they're trying to support a large number of developers and trying to share knowledge around what kind of events they can listen to, the schema is really useful for that. EventBridge can discover what kind of events are coming through your system and automatically register schemas for it. And then you can use EventBridge to generate code samples or code bindings. So if you're using an object-oriented typed language, it can generate classes for you, for example.
Yeah, that's
really neat for those. Absolutely, yeah. It can get really difficult if everything is dynamic and event-driven. If you don't have types, it can get pretty difficult to kind of understand the structure of events and what properties are supported. And then you've got the archive. So EventBridge Archive allows you to have retention on those events, so you don't lose them, because they're otherwise ephemeral, really. If nobody's listening, if there are no rules, the events magically disappear. But if you've got an archive, you can actually replay events. So you can add rules, change rules, fix problems, and then replay events, which is pretty good for resilience.
Yeah.
should we go through the process of using EventBridge? It's pretty simple, right? But I guess it depends. What are the steps involved? If you wanted to start sending and receiving events, we talked about how to do it with SQS. How do you do it with EventBridge?
Yeah, I think it's a good thing to split the process in two parts. So sending events and receiving events, because of course you care about sending events only when you are creating your own custom events. If you want to listen for AWS events or third-party events, you just get them. So you just need to focus more on the receiving part. So if you're trying to create your own custom events, basically the first thing you need to do is select a bus that you want to use. There is a default bus, so I will say that most of the time that's good enough, but of course you also have an option to create more specialized buses if you have to. The other thing, you have an API to send events, so you can do that of course through the SDK. It's probably the most common pattern, or you can just call the API or the CLI, and there is a specific interface that you have to use, but it's pretty free-form because you can structure the event in pretty much as you want. It's a big blob of JSON, and we'll talk in a second more about that. And then finally, when you want to listen to the event, you'll need to create the rule, and the rule also is another JSON object with properties. So let's zoom in into those two JSON objects. So when you create an event, there is kind of a best practice that is pretty much something you will see also in the AWS events and the third-party events as well. And there are like fields that are expected to be there, and they have a meaning. So, and these are the ones you will be using also when matching for those events. The first one is source, and source pretty much describes who is creating the event. So it could be your own service, maybe, I don't know, again, in the example of an e-commerce, it could be the order service. So you could literally say source order.service or something like that. In the case of AWS, you will see something like, I don't know, AWS.states, for instance, for step functions. And for third parties, I expect that you have something similar, for instance, I don't know, Salesforce I don't know, pipeline maybe. Then another field is detail type, which is a little bit more descriptive, and it tries to describe the specific type of event that was generated by that source. For instance, in our e-commerce example, that can be order created. In the case of AWS, sometimes they tend to be a little bit more verbose, and they have like entire sentences, like step function execution status change. And it's like an entire sentence that you need to match on. And finally, the most interesting part is the detail attribute. And generally, you can use that as you want, meaning that it's an object, and you can store inside that object all the data that you think is relevant to describe that example. And this is where it gets a little bit tricky, because you have a lot of freedom, you need to be careful. And on one side, you can say, I'm going to just store the minimum amount of data that represents this event. For instance, I don't know, if it's an order, just the order ID. On the other side, you might store all the data that represents that order, right? And the two sides are basically, they will force on you different constraints. If you go with a very minimal approach, maybe whoever is consuming the event will need to query different data sources or fetch additional data somewhere else. So that might be consuming, that might be costly for you.
Yeah.
Or on the other end, if you end up with very big messages, that can also be a problem. Especially if you're storing these messages, you might incur an additional cost. I'm not really sure if there are limits on the sides of the payload, but we'll talk more about limits later.
I believe it's the same as SNS and SQS actually, so 256K for the whole message. Yeah.
So yeah, be careful that you also have to respect that limit.
Yeah, absolutely. So, yeah.
One suggestion there will be, try to start with something that is relatively small and that you think it makes sense. And then if you realize over time you need additional feeds, you can always add them later.
Yeah, it's interesting when you talk about event-driven architectures, people say, oh, you should do event-driven architectures because it means you're then loosely coupled. As if it's like a very clear yes-no thing, loosely coupled or not. But I've heard the term semantic coupling being used. What that means when you're relying very tightly on the structure of an event and all its fields, This is a form of semantic coupling, so you still end up with it. It's not the same as having location coupling or time coupling, but it means you're bound to the event that you're used to seeing. So it makes it very difficult for the producer of that message to change it and to change the structure of their data types over time. So you really have to get that balance right.
Yeah, I think to all extents you should consider those messages as an interface, right? Because as soon as another service is starting to consume them, then you might break things if you suddenly change dramatically the structure of the events.
Yeah. For example, you mentioned that in the source field you might put the order service, and so if somebody says, oh, well, then I should match on the source because I want to get order of events, so I should match on the order service. But it probably doesn't make a lot of sense to match on the source a lot of the time because this is kind of coupling to the producer. It makes the detail type is usually a little bit more semantically meaningful, like order.created or order created. That sounds like a lifecycle event that you can use, and you don't need to match on the source then.
Yeah. What else can we add? We mentioned that you can use this to communicate across domains. So it could be a good way to do event choreography. And we gave you a few interesting details. Other interesting detail that could change, I suppose, the way you implement the integration between services is that if you really need a semantic that is like exact once processing of a particular event, it's on you to do that. Like you need to provide your own deduplication IDs and you need to handle duplication because by default you get at least once delivery. So you might get the same message more than once. And finally, another interesting detail is security. You need to, of course, use IAM and define all the resource constraints, but you can be very, very granular. And for instance, you could say that it's not possible, for instance, to create a rule that is using, I don't know, certain detail types. Like you can limit also the structure. You can limit based on the structure of the events. And that can be useful because, of course, if you have total freedom on listening for events, that can become a side channel for services to listen for information that they are generally not allowed to listen for. So you might be very strict in that regard as well. An interesting thing is the other side of the coin, I suppose, is how do you actually write the rules? Do you want to tell us something about that, Owen?
Yeah, so when you create a rule, you can create it using CloudFormation or Terraform or the API or the console. And the rule, you'll define the pattern, but you'll also define the targets. And for targets, we mentioned you can target a Lambda function, you can target an SQS queue or another event bus, lots of other services. But you can also do mappings. So if you want to transform the data, if you're transforming it to a HTTP destination, if you want to match the required payload structure that's required, you can do an input transformer on that, which allows you to extract out fields and map them into a different kind of a structure. You can do that with any event, actually, and any destination. You've also got destinations that you can configure that are specific to an individual service. And examples of that would be Kinesis or SQS. So with Kinesis and SQS FIFO, as we discussed the last time, you need to specify at what level you want order guarantees. So with Kinesis, you might put in a partition key, and with SQS FIFO, you could put in the message group ID. And when you write an EventBridge rule that targets one of those things, you can say this is the field that I want to become the partition key or the message group ID. So it makes sure that if you've got events coming in through EventBridge, you can specify the ordering you want or the shard essentially that will be processed. Now remember that EventBridge doesn't give you any order guarantees because it's not that kind of service. So you don't have order guarantees on the input side. So it's really more or less about doing best effort ordering or just controlling the shard they get allocated to so that you can process them concurrently. That's really the benefit there. And another example of that would be ECS. So you can fire off an ECS task, so run a container in response to an event, And ECS task configuration in a rule will allow you to specify what container image to use, what the task definition is, all of that stuff. So there's so much you can do with this. It's worth looking into the CloudFormation documentation. I always find that's a good way to see what are all the configuration parameters for these things. It really does allow you to integrate anything with almost anything.
Yeah, the cool thing about that is that most of the time it's so configurable that you just need to write the right configuration to achieve a good integration. You don't even need, for instance, to write a Lambda to reshape the data and call the destination service, which is something you maybe would think you will need to do. But because you have such flexibility, you can probably build sophisticated integration without provisioning any compute functionality. It's just EventBridge configuration.
Yep, and that's a good thing because, it might be a little bit more difficult to troubleshoot an input transformer than a Lambda function. That's the trade-off. But you don't have the latency and the extra Lambda function to manage. So you just got to pick your battle, I suppose, and figure out which is best for your use case. So since I mentioned latency, should we start talking about limitations and constraints and performance characteristics?
Yes, I think that's a good follow-up to how do you use EventBridge. Yeah, I think that the main one is latency, like you said that already, but how different it is, for instance, from SNS, where you have very small latency, like we're talking about 30 milliseconds, I believe, in the case of SNS. With EventBridge is a little bit unwavy, but I think it's generally around half a second, which is quite different from SNS, right? SNS is very performant. EventBridge, I suppose you need to start from the premise that you don't really care about extremely fast delivery. It's going to happen relatively fast, but not like milliseconds fast.
Yeah. I think this is exactly it. I mean, this is one of the rules where you can say, am I going to use EventBridge? If you need strict performance and latency, high throughput, you have to go with SNS or one of the streaming solutions. But if you're talking about, I just need to react to business events and process them, and it doesn't have to be if you want to fulfill an order, half a second is probably not a significant latency in the grand scheme of things, if you're talking about package delivery. But if you're talking about a user who's clicked an action and maybe you're going to do some processing on it, they're waiting in a web browser on a mobile device and they're waiting for a green tick to show that something has been processed, you might think twice about EventBridge in that kind of flow because the guarantees, like the AWS documentation says, typically around half a second. So it's not exactly confidence inspiring if you're looking for real-time event processing. So
I suppose
it could be a good idea.
That becomes especially true if you have a cascade of events depending on one another. Of course, that effect can compound. So be even more careful if you have that kind of situation.
I would still say that for a lot of cross domain events and even inter microservice communication, this should be sufficient in vast majority of cases. And I would recommend against using this latency limit as a false argument just to reject EventBridge and go with something that could be really more complex, because EventBridge is so simple and manages so much for you that it has the potential to save you massive amounts of engineering time. So it's worth sticking with it, and only if you really need to tweak performance, you might need to deal with optimizations for specific cases.
Yep. There are other limitations. This is worth mentioning quickly, but nothing extremely special. For instance, you have invocation quotas. They are slightly different depending on the region, so watch out for that. They can also be increased if you need to have more invocations. Also, there is a limit on the number of put events that you can do over a certain period of time. There is a number, I think it's 300 rules per bus, but it's something you can get increased if you need to create more rules. And also for every single rule you create, you have up to 5 different targets that you can trigger if that rule matches.
Yep.
In terms of pricing, is there anything interesting worth mentioning?
But the pricing for sending events is pretty straightforward. So I think for every region, you're looking at $1 for every million events, and that's whether it's custom events or third-party events or AWS events. So $1 for a million events.
I think in the case of AWS events, that counts only for the ones that you need to explicitly enable, like the S3 objects. But I think not all of them are actually charged. Right?
Absolutely. Yeah. They're sent by default. They're sent already, even if you don't know it. So that's true. You're not going to be billed for that. There is an additional cost, though, for things like HTTP destinations. It's like a supplemental cost of 20 cents for a million deliveries. And those features we talked about, like archive and replay, those are the areas that you might want to be a little bit more careful about when looking at pricing. Because if you're archiving events, sometimes you don't notice that the volume is escalating. And if you've got millions of events, you're going to be charged per gigabyte of archive per month. So that's an ongoing cost that will escalate over time. And replay, you'll get charged by the events processed. Replay is probably not something that you're going to do as part of a programmatic workflow. It's probably more likely to be done as part of remediation in the event of a failure. So it's just important to be aware of. And there's also a charge for a schema registry as well, in terms of events ingested when you're discovering schemas automatically. So that's the pricing spiel done. And I think one of the things that is challenging with all event-driven systems is how do you test it? And you've been reading some pretty good articles on this, Luciano, and I know Paul Swale has covered this in detail a couple of times. What do you think are the best recommendations there?
Yeah, I think at least for me, the main pain point is to make sure that the rules that I write, like the patterns, are actually doing what I think they should be doing. Because this is, of course, a JSON-based language with its own nuances. Like you have a lot of power, but you need to learn how to use the different constructs to do the pattern matching. And of course, you need to find a good way to test if your rule is actually correct. And I found that there is a little bit of friction, maybe something to be improved in AWS in terms of the tools you could get to actually get that reassurance that your patterns are actually doing what you want them to do. And so there aren't really a lot of great ways to do that in AWS. What I discovered is that there is an API called test event pattern that you could use either from the CLI or from an SDK. And with that API, what you can do is send an example event and your pattern, and that API will just tell you true or false based on is your rule actually matching that particular example of event. So that could be a good way of testing things. It's just a little bit annoying that you need to write either as code through the SDK, or if you want to write it through the CLI, like it's very hard to write JSON in the CLI, especially if you have big events or rules. So maybe an area where somebody can write a little tool or a little UI to do that would be definitely useful, at least for me. Maybe AWS itself could do that. That would be amazing. Then in the article that you mentioned from Paul, it's actually a really good article, and it goes in depth in terms of all the things that could possibly go wrong when you start to use EventBridge. Like from the moment you publish, are you actually able to publish? And if not, why?
Yeah.
The moment you try to consume the message, are you actually receiving the message? And if not, why? And then after you receive the message, are you actually processing it correctly? And if you fail to process it, what can possibly happen? So that's an interesting article, and if you are interested in all these possible edge cases, we recommend you to check it out. There are another couple of tools that can help you in terms of troubleshooting whether you are actually delivering like from source to destination correctly. One is something called EventBridge CLI. Again, we'll have the link in the description. And this EventBridge CLI, it's a tool written in Go, I believe, that is very interesting because you just run it locally and it will provision in your account a rule that you are actually defined, that's the one you want to test, but it will automatically dispatch that rule into SQS, and then it's going to create for you, it's going to poll at the CLI, so you get like an interactive CLI. It's going to keep polling from that queue, so you can start to try to fire events and see if they appear in your local terminal. So it's a very powerful and convenient way to test that your patterns and your events are actually connected correctly together. And I think there is another tool which is probably similar from Lumigo, but I haven't used that. So we'll put the link in the description as well. Other interesting tools are EventBridge Atlas and EventBridge Canon, which help you out as well with writing the events and testing them and sharing them in a team. So I haven't used them extensively, so I cannot give you a lot of detail, but definitely interesting to check them out.
Yeah. EventBridge Atlas and EventBridge Canon both come from David Boyne, who's also tweets and writes a lot about EventBridge and has some really interesting tools. So yeah, definitely worth checking those out. Should we talk about integration with SQS? Because I know we've got we talked about DLQs last time with SQS. I know that you can use DLQ with EventBridge, which is really good because EventBridge doesn't give you reliability built in. If you don't catch the event, if you missed it, it's gone, right? It could be in an archive, but it's essentially gone. But it does have retry policies, so you can configure retry rules in your rule, and you can set a DLQ as well, and then your undelivered messages will go to SQS. But when do you know? So here's an interesting one. When do you decide to process things directly using a target that might be a Lambda function? Or when should you put an SQS queue in between those two things so that you get that extra piece of resiliency?
Yeah, this is something that I suppose we mentioned also in the previous episode about SQS, that SQS can be used in general to give you that extra peace of mind that a message is actually being recorded and then you can consume, you can retry. So I think that should answer your question, right? Whenever you want to have that use case, that when you really care about a message and you want to be sure that it's being processed, I think it's worth putting an SQS in between and then consuming the message through SQS rather than letting EventBridge invoke directly your target. In other cases where maybe you don't really care that much, you can afford to lose a message or two. Probably it's not worth it. You can just skip that integration and go ahead with that.
Yeah, that's a good call. Do you need best effort durability or must-have durability? I guess, isn't it? Okay, cool. What else should we cover relating to EventBridge?
I think I will just mention a few additional resources. I really like the work that Shane Bristles from the Lego group has been doing around EventBridge. So definitely check out his blog. Again, we'll have a link in the description. There are, I think, 6 or 7 different articles that cover pretty in-depth, like tutorial style, how to do different things with EventBridge. And also there is a video where he's talking a lot about different characteristics of EventBridge. We'll have a link for that as well. And I think
that's really good. It's good to see how I think Sheen in that talk gives good examples of how they structure their events, and they've got a different style to what we mentioned in the detail, which is really interesting and really worth a watch. So yeah, definitely recommend that.
And I think with this you get a pretty good overview of what you can do with EventBridge, how to use it, what to watch out for. So this is it for this episode, but make sure to follow and subscribe, because in the next episode we'll continue the series about event systems. We'll be talking about SNS, Kinesis, and Kafka. So stay tuned. We'll talk more about this stuff. Bye.